everyone, welcome back. We're going to continue with the bill of quantity. Now, one thing I have to explain, the material that you're going to calculate or bill of quantity sections depends on your knowledge and on your thinking. For example, after excavation, you can start doing, for example, form work, step by step, to think of them in order to know which work you have to do. In this manner, if you think in this manner, let's say you did the excavation. After excavation, what will happen? You most probably have sand or concreting under the foundation. Then you can create another sheet, or you can just simply add at the bottom of it concreting. But remember, if you do concreting, you have to think, where else do you have concreting? So you have to add all of them under each other. While you're doing this for one project, two projects, later you will realize that you know how many type of work you have it in a construction. Then you can categorize them the way that you want. For me, I will start with backfilling. Now, after we did the excavation, let's say that I haven't calculated the reinforcement, nothing for the foundation, concreting, formwork, nothing. But I'm imagining that we finished the foundation. I'm thinking about the soil work first. I want to finish the soil work. Excavation is related to soil. And what else do we have related to soil? If we have some part of the building that needs to be filled, because when you do excavation, when you build the foundation, afterward maybe some place is supposed to be filled. So let's say, do we have something like this? Now, how do we know if we have a filling? So backfilling. Are you filling it back? Backfilling. Now let's say, how do I know if I have backfilling? In order to know backfilling, I need to go to one of the sections. I'm going to go one of the section, and I know the location of the, so this is, this is a 0, 0, the ground level, and I know something that the foundation that I have it, it is right here. This is the foundation I have. It continues till the end. So the place that we're going to live, it's kind of plus 50 here. You'll see it here. This is plus 50. It is the level of the first, basically the ground floor, the slab on grade, we call it. So in between them, this empty supposed to be filled, which something given to us. If you see that there is some things that written here that will tell us that how do we have to fill this part there. Well, so I need to know this spacing, yes, how much this spacing is supposed to be in order to calculate the things that we have it. Well, let's see, what do we have here. There's explanation that you can see it here. This will tell us the layers. We have compacted soil, so this is the bottom one. Then we have 15 centimeter blockade, which is this guy here. And then we have 10 centimeter plain concrete, which is basically this one. And above the plain concrete, I have leveling concrete. So for me, which one is important? Well, this one, those two at the bottom, mainly they are blockade and compacted soil. This is for backfilling, I need them. Well, let's calculate the distance that we have it. We already know that this is 0, 0. This is 0, 0, and top of here, it's 50 centimeter. Now, when you say, is this, let's just make sure that we're calculating exactly. So in AutoCAD, why the drawings better to have AutoCAD? We need to know that if this is exactly the top of the slab, if this is the top of the slab or top of the layering, the leveling layer. Look, this is the green line, yes, the green line. As we said here, this is the 4 layer, I have it here. There will be compacted soil, for example, somewhere. and there is the blockade, is the compacted soil, this is the concrete, and top of the concrete we have a small layer which is the 5 cm leveling. Now this is at the green line, it's plus 0.5, which for me, if I wanna take this one, I will only take 10 centimeter out of it, because this 5 centimeter, it is above the 0.5. This is basically, let's change it to 50 centimeter to have a better understanding. This is 50 centimeter above. So this 5 centimeter is not at the green, it's above the green, so I don't care about this 0.5. 10 centimeter, so I know now here how much it is, 0.4. And I know that the level of the concrete basically somewhere it is 0, so how much I have it? 40 centimeter I have, which will be filled. Out of this 40 centimeter, so now I realize that, because here it's the bottom of this slab is 0.4, and we know that our top of the foundation is 0, so we have 40 centimeter to be filled. Out of this 40 centimeter, 15 centimeter is blockade, so 15 centimeter is blockade. The rest of it will be compacted soil, which out of will be 25 centimeter. So 25 centimeter for compacted soil, because they made it variable. Why? Because they will take will leave 15 centimeter for blockade, and the 25 will be compacted soil. Now, I need you to understand something. In soil mechanics, you studied swelling factor and compaction factor. Now, when we did the calculation for foundation, we found out we have 84 cubic meter of a soil excavation. But when you excavate soil, it will be loose. It will be expanded or it will swell. You know this one. For example, if you have something, if you take this soil out, it will be something more. The volume will increase. Why? Because they will be loose. There will be a lot of void inside it. This is something we know, that if this is 84 cubic meter, this will be bigger than 84 cubic meter is in the volume. It's important to know this characteristic of soil, because when you trying to manage the loading of this soil out of the project, or sometimes you bringing soil to the project, you have to know the property of the soil that you're ordering, or the soil that you have it, how much will be the volume of it, like is it going to swell with 0.1, 0.2? It's important because this volume is the theoretical on the ground, natural ground, but when it comes out, it will swell, it will be more. The same thing for the compacted soil when we have it. So we have compacted soil, yes. Now we realize that 25 centimeter we have compacted soil. We will calculate the amount of soil, compacted soil required. Maybe you can use the soil that you have it back into it, or it can be other soil, will bring it to the site. So also for the compacted soil, you're supposed to know that if you have 1 cubic meter compacted soil, most probably will bring more than 1 cubic meter, because when you compact it, the void will be like smaller, it will compact, then it will fill the 1 cubic meter. This is supposed to know it regarding to this material. So backfilling, we have what? We have compacted soil, compacted soil. Now I know the thickness of it, like the thickness of the compacted soil, I know it is 25, but where is supposed to be filled? Where exactly supposed to fill? I mean, if I check the other section, it's the same thing. Yes, under the same, we have the same thing. Well, if you want to calculate the area where we have to go over the foundation. Now, when we dig basically, this was the excavation we have it. Yes, this was the excavation we have it. Let's see if I can make something for you understandable, how we can imagine the feeling that we have it. It cannot, because it's not a 3D, so it's hard to imagine this one, but I'm trying to make a 3D drawing. So you will fill in between all of these columns basically. All of this area will be filled, all of this area will be filled except the columns area, except the columns area. So when you're trying to fill, because you excavated this much, so, okay, still haven't worked properly. So you will fill the area except the location of the columns. So we have what? We have minus this time. You will realize that we will do the compacted soil, the whole area, and the columns. So let's see if I can manage this one. It's a bit. So imagine that you have this. This is the land that you have it. After excavation, you're going to what? For example, let's say you did it and you excavate this part like this. So this is you're going to excavate it. Or this is excavation after did it. Then you fill this part here. You fill this part with a layer. But sure, the columns, you have the column, yes? I cannot do anything with the columns. So sure, I have this column is coming out. This column is coming out. The rest of the column like this will come out. So this is the way you have to think. You have to fill this area without, for example, the columns. Now, if there's going to be something in between them, is there going to be something in between them? This is something else. The round, maybe you have a wall. If it is not given, we imagine this manner beside all of this will be filled except the location of the columns. Sometimes they will provide us what? They will provide us a beam here or in between them beams, but nothing provided here, nothing we have it on the plan. So we assume that it will be filled except the location of the column. So basically I have to do what? I have to calculate the whole area and take the area of the columns. So we assume that the columns will come to the level at the bottom, and the slab will come over here. The slab will come over here. This is how we're thinking there. So in the case we have it here, the total area, we already know it, yes? It's the mat foundation area. It's the mat foundation area we have it, isn't it? Only one filling it. It is the same area of the mat foundation, 9.6. However, the height of it is compacted soil, it's 0.25. So I can just simply copy this one, since it's Excel, Control V, it will calculate for this one here. This is, in Excel, when you copy paste, and the things will come down with it. So we have 42 cubic meter backfilling, but this is not all of it. Why? Because I need to calculate what? The minuses. So the minuses here, how many columns do I have here? Yes, how many columns do I have here? So I will write it here. This is compacted soil. I will write it here, the same thing, compacted soil, but I will say minus. I'll put this one as minus. Now, why? Because I have to calculate some minus. We have it. Well, how many columns do I have? I can just simply look at them to see if there's similarities. There's similarity in the columns. I need to calculate the area of the column. We have column which is 25 by 60 years. I can write it like this: 25 by 60 columns. How many of this column do I have? Let's make this one bold. How many of this 25 by 60 column I have? So this is what similarity. This is one, the same area. 2, 3, 4, 5, 6, 7. Let's see if you have anything down. 7. We have 8 25 by 60. 8 25 by 60. So I'm just gonna write here 8 of them. 8 columns we have it. Well, the column, the length, and basically if you write it out, 25 by 60, which is 0.6 0.25, 0.25, and you are deducting the same height of the backfilling, because you had 25 centimeter extra, you took it. That 25 will be the same thing. That 25, it's the depth of the compacted soil, so you're taking the area out of it, well, this is, it can be here, so I'm going to bring this one, Control C, Control V here, but we know this is supposed to be minus, something minus. Why? Because it is minus, it's the part of the minus, we have it here. Then what other type of column do I have it here? Let's start with the top to not miss anything. We have 120 by 25, we have two of them, 120 by 25, so I'm writing it under it, 120 by 25 column. Then this is two of them, I have it, which we said that 25 by 120, so 1.2 by 0.25, and this will be 0.25. Now I could add this one to here as well, but I didn't, because this is 1.2. You can think of it as 2 25 by 60. The same thing here, 2 25 by 60. I could add, for example, 4 to this one. It would still be possible, but I prefer to have them separate. If there is any mistake, I can come back to them. I know where is the mistake. So you can do things, but separating them will be better for checking. Then I have one here which is 150, 1.5 by 0.25. Again, the depth of the backfilling is the same. We have one of this, and this is, we write it 120, 150 column. The same thing, I can just simply use this one to get their value. Still I have more column. I think the 2 column remain, which they are the bottom columns. We have 2 round column, we have them here. Their diameter 40. Now, in order to calculate this one here, the diameter of this one, we have 2, which is D40 columns. Those are round columns, we have it. You can calculate the area of it. Yes, you only have radius. Now, sure, the thickness of the compacted soil is the same thing, and we don't have width and length here. So, in any way you're writing the radius, it's 0.4, but the area of this one cannot be just simply the same as the others. So I'll say that pi, if you want to go into detail of them, there will be pi r square. Well, this is the diameter 40, so I need it here, will change, okay, let's say pi over 4. If you know Excel, so you can write this one. This is pi over 4 times diameter square. This is the area, multiply by the thickness, that will be volume, multiply by how many we have it, 2 of this one. That's going to be the volume of both of them, which is going to be something like this. Now we have something here, 2 round circles, which we took them out. Those are all of them minus, so I need a minus under here as well, minus under here. Now the total, so the total basically, or I can write the total compacted soil will be equal to summation of those values here. So you realize that this is nothing. Yes, look, I did all of this calculation. How much did it change? It was 42 cubic meter, became 41.4. So all of this small columns location, how much was this? 0.6 cubic meter. But if you want to do, for example, a detail, this is, you can do it. Let me just small this one. That will be, even this will be enough. 41, this is cubic meter. So this is the total compacted soil. So we had backfilling, make this one backfilling, we had compacted soil, so let's give a spacing here. Then the back soiling, we have the plus and the minus of them. Their summation became this one. Then what else do I have? What else do I have beside backfilling, compacted soil? We had the blockade. So we have the blockade because we already know the blockade as well. It's given to us because the blockade was 15 centimeter, the same area. So look at here, the calculation sometimes will be much easier. Sorry. So this is, it's exactly the same area, yes, the same area. So what we're going to do, I can just simply copy paste this one and just change the thickness. So we have the blockade, yes. Now the blockade also, I'm copying the same thing. Why? Because it's exactly the same. So I have to rewrite them again. Let me just bring them, yeah. Let's even bring the summation, everything. So instead of this one, I will change this one to blockade, and again the same thing, we have it here. This will be blockade minus, we have it the same, because the same columns will take that, but this time is not 0.25, will be 0.15. That's it. So this will be changed and I'll directly get the answer. I don't need to go through again all of this. Why? Because it's the same. Two layers over each other. When you did calculation for the layer at the bottom, the top layer will be the same thing. The top layer will be the same thing. So total blockade will be 24.8 meter cube. Now what are the blockade material, the compacted soil material? If they are the same, most probably they are not the same. If, for example, the excavation that you have, it can be used for the compacted soil, you can sometimes combine them together. This 84 can be used to fill, half of it can be used to fill the total compacted soil, if it is possible. Because the excavation that you did, the soil that you have it can be used to backfilling if it meets the requirements. If not, you have to provide soil that required for the compacting and the blockades, which is mainly aggregates and gravels, to do. Well, what else do I have it here? If I basically look, detailing, you can go with more detailings if it is required. What else do I have it here? Now, there is a problem we're facing it here. We have to take these areas out. Now, the mat foundation that provided to us, the mat foundation that we have it, there are some part of it, it is possible if you go into detail of it, you can, let me just explain for you, and it's for students to know that if you want to go into detail, you have to do these things as well. For me here, thinking in this manner, it's okay. Well, if you check the mat foundation was around the building, something like this. The columns are inside it. Now when you fill up, there is a question: is this area need to be, for example, does it need compacted soil? Does it need that blockade there? Now this question comes from where? Do you have walkway around the home? Do you have a pavement, like a concrete pavement around the house? If you have it, so this calculation here is totally fine, because there will be a walkway. People basically, most probably you have it here that people will walk around this part, will be pavement, so with the concrete or tiling, whatever it is. So in that case, it is a part of the calculation. But here, unfortunately, there is no side wall clear on the house. So if you want to go into detail of this one, you can just encounter the filling that required only for the part of the only for the building. This is possible thinking. If you don't have this around, so you should basically fill only around the building. If you know that there is nothing around, which most probably we have it, so this is the area that you use it for what? This will be the area that you're going to use for the backfilling, for the compacted soil, the things that you have it. This is something can be as well part of it. If it is even here, you can add the staircase. So I'm going around the building if I wanna calculate if there is no sidewalk around the home. I can simply deduct this one as well as a minus to add it there. Like for example, I did this one, yes, I can just simply add some minus extra here, some minus extra here to deduct the area that I have it around it if there is no sidewalk. So let's say if there is no sidewalk here, what will we do? We have to take care of this 60 centimeter around, because there's 60 or 30 we have it around. That's something like this. There was something more around here, so we're gonna take care of this one by extracting. So those part, you will extract them from. But as we said, that sometimes the practical people not gonna do this one. When they do, it's all of the foundation. They will just fill everything, and later they will do the rest of overhead. Something optional, which I leave it for you if you want to go into detail of them. So this is, let's say that we have come to the filling part, which is we did the so this was the bottom of that. Now here you might think that okay, we can do it around here, that this is the place that can be used for filling. As I told you, that if there is no sidewalk around it, you can use around the building in order to use for this compacted soil. On the other side, the same way. Look, there is most probably we have something around the house. If there is not, we only consider within the home for this blocking. So if this is the case, let's say that I did this one based on the foundation, considering what? Considering around the house there will be a sidewalk. Now if I want to do this one based only on the area, what will we do? There is a way that we can do it. So we have to come here, and you can divide the home into different sections, different areas. But the same thing, you have the columns that you have to take it out for. So you will divide this one into smaller area, or as I told you, you can take from this corner like as one area like this. Let me just show it to you. Something like this from this corner. So this is one area, you can take it up to here like this. Sure, you have to take the column out of it. Then you have to deduct this one. This is the minus. This part will be the minus. Then this part will be extra. You'll add this part extra, and this part extra. So the places will be like this. You will have this minus here. I'll just change them their color. So you'll have minus here, you have a plus here, and a plus here, and this is basically was plus, the big one. This is a possible way to do the backfilling and the blockade. Sure, the columns, since they are continuous, you have to use them as the minus. This is also possible, which I can leave it for you to practice to see that how to be able to manage this one, which you already know. The idea what we got the thicknesses from somewhere, the areas we can get it from the drawings. By the way, if you have the drawings in AutoCAD, it's very easy because you know how to use AutoCAD, so you can take dimensions easily. You can get the dimension of this side, dimension D, you can write them down inside here. This is possible as well. Now this is what we have for this project for the backfilling and compacted soil. Now we don't have anything related to the soil because we finished the foundation. Basically, let's say finish the foundation, we filled it, we put that one, then in the next one we can start with the plain concreting, then we can go for normal concreting. There will be a lot of other things coming in the next videos. Thanks for watching.